Alright, let's look at the homework 11.9, problem number 9. Alright, so we want to find the interval of convergence of this power series. Alright, so let's do that. Alright, so I'm going to do a ratio test. Okay, so you have a limit as n approaches infinity, then absolute value of an plus 1. So I just put x to the n plus 1 over n becomes n plus 1 squared, right? Then divided by an, so I just have to multiply by the reciprocal of this. So we have n squared on top, and we have x to the n on the bottom. Alright, then we're going to do a cancellation. So we can cancel. So we have x to the n here. You have one extra on top, so I'm going to scratch that out. So you have 1x left over here. Alright, then I'm going to pull that guy out. So absolute value of x, it has nothing to do with n. So I pull it out. And what's left is limit as n approaches infinity. Right, so you have n squared over n plus 1 squared. So I'm going to just go ahead and write n over n plus 1 squared. Right? And to evaluate that, let's say if n goes to infinity, the numerator goes to infinity and the denominator also goes to infinity. So what I'm going to do is I'm going to actually squeeze this limit inside the square first. So I'm going to have absolute value of x times, right, so we have to square that later, but we have a limit as n approaches infinity of n over n plus 1. Then I'm going to just multiply top and bottom by 1 over n. 1 over n, right? So we will get this absolute value of x, and then we have a limit as n approaches infinity, right? You have a 1 on top, and then n divided by n is 1 again, and 1 divided by n is 1 over n, and then squared. Right, as you can see that as n approaches infinity, 1 over n approaches 0. So you end up getting 1 over 1 plus 0 squared, which is going to be 1. So this is going to give you absolute value of x. And we want this to be less than 1. Right, so from here, we can get the interval. So interval is going to be, removing the absolute value, it's going to be a -1 to +1. Right? Then we have to check each endpoint separately. So let's check the endpoint here. So when x is equal to -1, right? Then this series is going to look like this. N goes from 1 to infinity. Then you have a -1 to the n. So you have a -1 to the n. And then you have a 1 over n squared. All right. So you can see that this is going to be an alternating series. And this right here is our Bn. All right. And you can easily check a couple of things. So by doing an alternating series, right? So number one, we have to show that the Bn is decreasing. So you can see that the Bn is 1 over n squared. And if you compare that with 1 over quantity n plus 1 squared, which is a Bn plus 1, since you're increasing the denominator, so we know that this is going to be smaller, right? And number two, if you take the limit of Bn, which is 1 over n squared. And obviously this is 1 over infinity, so this is going to go to 0. So it satisfies the two conditions for alternating series. So we know that this is going to converge. Right? But when you look at, let's see, when x equals 1, so let's see, I'm going to go down here, x equals 1. Right now, this is going to give us a p series, right? So n equals 1 to infinity, and this is 1 to the n is going to be 1 over n squared, right? Then this is going to be a p series, so p series with p equals, right, p value is right here. So p equals 2, which is greater than 1, which means that it's going to converge. Right? So it's going to converge at both ends. So interval convergence for this guy is going to be square bracket -1 to +1 with a square bracket. Square bracket indicates it's inclusive, so we're going to include -1 and a +1. Right, let's type it in. Right, so we have square bracket, so you have to put a left to square bracket, -1 to +1 and a right square bracket. Right, let's check the answer. Alright, I came back and it looks like we got the correct interval convergence for f. How about the f prime? Right? So when you look at the f prime, the radius of convergence stays the same, but we might have a slightly different interval convergence. So first I'm going to go ahead and take the derivative. So we're going to take the derivative of f. We're going to get this. So f prime of x is equal to, right, so summation stays the same, so n goes from 1 to infinity, right, and the n squared is a constant, so we're going to put the n squared here, right, so the derivative of x to the n is n times x to the n minus 1, right. Then you can see that we can cancel n on top and one of the n on the bottom, right? So we'd end up getting simply a summation. N goes from 1 to infinity, x to the n minus 1 over n, right? So we got that. Alright, so we know that this guy has the same radius of convergence, so interval is going to be from -1 to +1, but we still have to check the endpoints. So we have x is equal to -1. Then you have a summation. N goes from 1 to infinity, right? So if you put -1 to the n minus 1, and then over n, right? So this is the alternating harmonic series, which we know that it's convergent, right? So it converges at -1, and if we try x equals +1, then you see that this is going to be, since it's positive, it's going to be just a 1 over n. So this is the harmonic series, which is divergent, right? So we're going to include -1, but not +1. So interval convergence for this is a bracket on -1, but a parenthesis on +1, right? So let's type it in. All right, so you have a bracket -1, and you have a +1 with the parenthesis. All right, let's check the answer. Alright, I came back and looks like we got the interval convergence for the first derivative. Alright, so let's look at the second derivative. Alright, so we're going to do the same thing. We're going to have to take another derivative. So this is going to be, take the derivative. So we're going to have f double prime of x. So this is going to be equal to, so summation stays the same and goes from 1 to infinity, right? Then you put n minus 1 in front, and then you have x to the n minus 2, right? Then you have n on the bottom, that's just a number. So we have that, all right? Then, so this is the series, and again, the radius of convergence stays the same. So we're going to check the endpoint. So let's try -1. So if x equals -1, right? And one more thing you can actually do is, since it stopped when n equals 1, the term is going to be 0. So we can actually start n equals to 2, right? Which really doesn't make any difference, but we can do that. All right. Then when n equals -1, we get this series. Summation n equals 2 to infinity, right? Then you have n minus 1. Then you have -1 to the n minus 1 over n, right? So I'm going to actually do the divergence test on this one. So I'm going to just take the limit as n approaches infinity, right? Then if you take the absolute value so that we don't have to worry about the negative sign, so you have n minus 1 over n, which is the same thing as limit n approaches infinity, right? So n divided by n is 1, and a minus 1 divided by n is n, right? And as n approaches infinity, this guy approaches 0. You know that here is going to be 1, right? Which is not equal to 0. So by divergence test, we know that this is going to diverge, right? And you can say the same thing about the when x equals 1, because you're going to get the same absolute value for absolute value of an. So you have n minus 1 over n, and for the same reason, these two guys diverges, right? So which means that interval convergence is going to be actually open interval from -1 to +1, right? So let's type it in. So we get -1 to +1, right? Let's check the answer. All right, I came back and looks like we got this one correctly as well. All right, that's it. I hope that this was clear.